Hi everyone. Now I am going to discuss the lecture 4 in units and measurement. Lecture name is Errors in Measurement. First I will explain what is the meaning of error. Error is nothing but the uncertainty in measured value, or we can say it is difference in true value and measured value. True value and measured value. Here we can take the magnitude of this true value and measured value. Sometimes measured value may be greater than the true value, or sometimes true value may be greater than the measured value. That's why error can be written as modulus of true value minus measured value. This is the basic relation for the error. What is the meaning of this? Suppose if I measure a length of an object, I have measured this length of an object. Let us consider that the value is 20 plus or minus 0.4 centimeter is there. What is the meaning of this? We can write the value of this length varying from the 20 plus 0.4, that is 20.4 centimeter. Minimum value is 20.04, that is 19.6 centimeters. The length of an object lies between the length L is there, no? That length of an object lies between 19.6 centimeter to 20.4 centimeter. Value will be lies between these two values only, like lowest value is 19.6, highest value will be 20.4 centimeters. Okay, this value cannot be less than 19.6, more than the 20.4 centimeter. Okay, and we can say that the value whatever the 20 is there, that is true value. This is the true value. This uncertainty, whatever the 0.4 is there, this is uncertainty in the measured value. Okay, so we can say that error is nothing but true value and measured value is there, no? So you will see that what is the true value and measured value based on the given values in any problem. Okay, now we can see I told that here true value is 20 centimeter. Uncertainty I told, no, that error in given value is length is, I can write it as delta L is equal to 0.4. Above case we can write the length L is equal to 20 centimeters. Overall I can write it as length can be written as L plus or minus delta L. Okay. Now if I take the any quantity Z, that Z is equal to, if I write like a plus or minus delta A. Nothing but this A is a true value, delta A is error in the Z. Okay, or error in the A value. Similarly, if I take the two values like a addition of the two vectors, addition of the two measured values, subtraction of the two values, similarly mean value, mean absolute error, as well as what is the relative error, percentage errors. If you want to calculate, we can use the some relations we can see here. Let us consider I am taking a measurement. In a measurement, let us consider the values are like this: A1, A2, A3, so on up to an readings. I have calculated the an readings. If I want to get the true value, my true value will be like this. I can write a mean value can be written as a1 plus a2 plus a3 plus so on up to an whole divided by total number of readings n. That is my true value. Okay, that is mean value. If I want to calculate the error in reading 1, I can write the value is delta a1 is equal to a mean value minus first reading magnitude value I will take. Similarly, error in reading 2, delta a2 is equal to a mean value minus a2. We can write the like this. If I continue for the all the n readings, what is the for nth reading error is a mean minus a n. I can write the whatever the mean absolute error error. I can write delta a mean can be written as delta a1 plus delta a2 plus so on delta an whole divided by the n. This is my delta an value. Okay. Now these are the general relation while solving problems. Also you have to keep in your mind, if readings are given, we can calculate the mean value as a true value, and mean absolute error you can take as a error in that value. Okay. Now I am taking like a different values. You can see, suppose if I want to calculate the relative error. Relative error can be written as whatever error in reading is there, that value divided by the true value. Error by true value. This is a relative error. Next, percentage error. Percentage error can be written as relative error into 100. Relative error into 100. We can write the percentage error in A can be written as delta A by A into 100. This is the percentage error in the given reading. Next one, if I take the different reading, earlier I told that how to add the two quantities and how to add the errors. Okay, we'll see now how to add the errors. Suppose if I add like a two quantities like A plus or minus delta A and B plus or minus delta B is there. If I want to add both the things, I will get like a whatever the original reading is there, that can be written as Z is equal to, I can write it as A plus B. Similarly, error in Z is, I can write it as delta Z is equal to delta A plus delta B. I have to write. This is whenever addition of these errors are there. Okay. Similarly, if Z is equal to A minus B is there, then I can write the error in Z is delta Z is equal to, again we have to write the delta A plus delta B only. Keep in your mind, error in measurement is that errors delta A, delta B, they cannot be subtracted. Always they will be added only. Okay. Similarly, if Z is equal to multiplication is there, A and B, provided that whatever I am taking is, provided whatever the delta A and delta B are small values. It indicates that delta A by A is very less than 1, delta B by B is very less than 1. In that case, I can write the relative error in Z is relative error in Z is delta z by z can be written as delta a by a plus delta b by b. If we want to, we can write the plus or minus in front of that. We have to add only these errors. Okay. Suppose if I want to calculate the percentage error in z, I can write the delta z by z into 100 is equal to plus or minus delta a by a into 100 plus delta b by b into 100. Similarly, if I write the z is equal to a by b is given, then I can write the whatever the percentage error in z is there, z can be written as delta z by z into 100 is equal to plus or minus again it is the percentage error in a plus the percentage error in b. Here also we can see that whether it is a by b is there or a into b is there, we have to add the relative errors. Okay. If it is a plus b or a minus b is there, you can see a plus b or a minus b. In that case, we have to add their whatever the errors are there, we have to add their absolute errors. Okay. In this case, relative errors we are adding. Other thing, if z is equal to a to the power of n is there, then if we want to calculate the percentage error in z, you can write it as delta z by z into 100 is equal to n into delta a by a power into relative percentage error you have to write. Okay. N into delta a by a into 100. If I take like z is equal to a to the power of m, b to the power of n divided by the c to the power of p is there, then if you want to calculate the percentage error in z can be written as m into delta a by a into 100 plus n into delta b divided by the b into 100 plus p into delta c by c into 100. The value you can see here how to write the powers. You should not subtract, like you should not write like a minus p into delta c by c into 100. You should write only addition of all the percentage errors we have to add. Okay. I hope it is clear for you. Based on this, we can solve the problems how to add the any absolute errors, how to subtract the absolute errors, how to multiply the any percentage or relative errors. Similarly, how to do the calculations related to the powers involved, like a power m, b power n, c to the power of p. Provided in all these cases, I am considering this value, you observe this delta a and delta b is very very small. Okay. In that case only errors are very very small errors is there, we can use this. Whenever these errors are very small, we can use generally differentiation method. Okay. These are actually by using differentiation method also you can get. So these things I will explain while doing problems also, we can observe clearly. Okay. Now I am moving to solve the some problems wherever requirement is their concept. If it is required, I will write the formulas also there. Now see here, I have taken a question in JEE from the JEE mains 2022. If z is equal to a square b cube by c to the power of 4, then relative error in z is what? So according to question, it was given that z is equal to a square b cube divided by c to the power of 4. Here they are asking that what is the relative error in z. What is the relative error in z? I can write the relative error in z is equal to, we can write it as delta z divided by the z, that is the relative error in z. Here a square is there, I can write it as the error in a, relative error in a is 2 times the delta a by a. Similarly, b cube is there. Whenever b cube is there, what you have to do for a square, whatever the a square error is there now, that we have to add with the b cube. Okay. 3 into delta b divided by the b. Next we have to add the error in C. Error in C is 4 times the delta C divided by the C. This is the relative error in the given relation. So from this we can see third option is the correct option. Okay. Now I am moving to the some other question. In the next question, they have asked that a physical quantity Z depends on 4 observables A, B, C and D as Z is equal to A square B to the power of 2 by 3 by root C D cube. The percentages of the errors in the measurement of A, B, C and D are 2%, 1.5%, 4% and 2.5 respectively. The percentage error in Z is what? I am writing now what is given value. Z is equal to A square B to the power of 2 by 3 divided by the root C D cube. Okay. Now the percentage error in Z. Percentage error in Z can be written as delta Z by Z into 100 is equal to, we can write the percentage error in A square can be written as 2 into delta A by A into 100 plus percentage error in B to the power of 2 by 3 can be written as power is 2 by 3 and delta B divided by the B into 100 plus you can write it as root C. Root C is nothing but 1 by 2 into delta C by C into 100. Similarly, you can see that D cube percentage error can be written as 3, power is 3 into delta D by D into 100. Now, if you substitute the values 2 into, according to question, delta A by A value is given that 2%. I am writing here 2%. Plus, we can see next one is 2 by 3, delta B by B. Delta B by B, they have given 1.5%. I am writing 1.5%. Plus, next one is 3, delta D by D. Delta C by C value is equal, sorry. Next one is 1 by 2 times the delta C by C into 100. Delta C by C into 100 is 4%. You can write 4% plus 3 into delta D by D into 100 is 2.5%. You write the 2.5%. If you add all the things, we can write the 4% plus 2 by 3 and this, if you see that this will coming like a 3% by 3%, 1 will get 1% plus this will be 2 times get cancelled, 2% plus 7.5%. If we add 4 plus 1, 5, 5 plus 2 is 7, 7 plus 7.5 is 14.5%. We'll get the fourth option is the correct option. Observe this. Okay, powers, I am telling that root C is there, no, in denominator is there. If you bring up C to the power of minus 1 by 2, it becomes C to the power of minus 1 by 2. That you should not write like a, while writing errors, don't write minus 1 by 2 into delta C by C into 100. Don't write the D cube. If you bring to the numerator D to the power of minus 3 it becomes, then don't write minus 3 into delta D by D into 100. So you have to take only errors should be added. They are independent and what they are how we are doing. Errors will be always will be added. Okay. Next question. A physical quantity y is represented by the formula y is equal to m square r to the power of minus 4 g power x l power minus 3 by 2. If the percentage error found in y, m, r, l and g are 18, 1.5, 4 and p respectively, then find the value of x and p. They are asking in 2021 JEE means they have asked this. I am taking y is equal to m square r to the power of minus 4 g power x I to the power of minus 3 by 2 is there. Now we need to calculate what is the value of error in y. Percentage error in y can be written as dy by dy by y into 100 can be written as 2 into delta m divided by the dm by m into 100 plus 4 into here r to the power of minus 4, error in r to the power of minus 4, you should not write like a minus 4 into dr by r into 100. You have to write the 4 into dr by r into 100. I am writing here, instead of writing delta y by y, I am writing dr by r only. You can use dr by r or delta y by y also. Reason is the errors whatever things are there, they are small values only. Okay, 4 into delta r by r into 100. Next we can write it as plus x into delta dg by g into 100. And next one we can write it as plus 3 by 2 into delta I by I into 100. I am substituting the values. Delta y by y value they have given 18 percentage. This value is 2 into dm by m. Dm by m value you can see that 1 percentage. Okay, and plus 4 into r value they have given. R value is given that r value is given that 0.5. You can see 0.5 percentage. Plus next one is they have given I x value you don't know that. Dg by g they have given that p percentage they have given. Plus 3 by 2 into L values they have given that 4 percentage. We can write it as 4 percentage here. If you see that first case, we can see last case 4 and 2 get cancelled 2 times. Now finally you can get the 18 percentage is equal to, we can write it as 2 plus 4 into 0.5 is 2 percentage plus xp percentage plus 6 percentage. If you write this, 2 plus 2 is 4, 4 plus 2 is, we can write it as 4 plus 6 is 10. So you can write it as you are getting like a 10 percentage you are getting. Okay, you just write the 18 percentage. Okay, and if you see that 18 percentage minus 10 percentage is equal to x into p. So now you will get 8 is equal to xp value will get. If you write the 8 is equal to x into p, according to question they are asking what is the value of x value as well as p value they are asking. So what actually you can get from here? So if you multiply that x and p values, you have to get like a 8. Okay, suppose you check the options here. According to options, first one if you multiply that, what is the x value and p values? Okay, x value is 16 by 3 is there, and p value how much is there? Plus or minus 3 by 2. Just I am taking 3 by 2. If I write the 3 by 2, 3 and 3 get cancelled, 2 and 16 get cancelled, we are getting 8, means it is satisfied. It is satisfied. Now we can say that the first option only correct option. You check other ones. 8 and 2. If I write the 8 is equal to x into p is there, no? Now x is equal to 8 is there, p is 2 is there. If you multiply 8 and 2, you are getting 16. So it is not satisfied. So from this we can say that the correct relation is 16 by 3 and plus or minus 3 by 2 is the answer. Okay. Now I am going to show the another question. Now you see here the current voltage relation of diode is given by I is equal to e to the power of 1000 V by T minus 1 milliampere, where the applied V is in volts and temperature T is in degree Kelvin. If a student makes an error measuring plus or minus 0.1 volt while measuring the current of 5 milliampere at 300 Kelvin, what will be the error in the value of current in milliampere? That's what actually question. Now I am taking error in current only they are asking. Now first I am writing I is equal to, given that e to the power of 1000 volt by T minus 1. This is my I value. We need to calculate the error in this. So how to write the error in this? Let us consider that I am differentiating this. Differentiate. I told already, wherever the errors are there, no, whatever errors are there, for small errors, we can use differentiation. we can use differentiation. I am telling, earlier I have written that whenever delta A is very less than A, then only relative error formulas are there, no? That we have written percentage errors and all. Okay, that formulas, that relations we will get. Generally, if it is large values also, we have to write the change values. Okay, now for small errors we can use the differentiation also. I am doing I differentiation. If I differentiate that, I will write the di is equal to actually the variable term. If you see that measuring in voltage is given 0.01 volt. Temperature is there as it is only. I am writing now delta I. They are asking di value, so we can write it as 1000 divided by the T into e to the power of 1000 volt by T, whole thing into, we can write dV, whole thing into dV. I have differentiated this, I got the value is this. If I see that what will be the error in the value of current, if they ask that what is the value of current in, so I am taking this is my first equation is there, that if you want we can write, otherwise leave it. Okay, 1000 by T, T is equal to, we can see that 300 e to the power of 1000 into V can be written as per the question, V is given V only, T is given 300. Now delta V value they have given 0.01 volt. Delta V value they have given 0.01 volt. You observe this carefully, they are asking what is the error in this. But if you see that I value also they have given some value, just you observe that I is equal to, I can write it as 5 is equal to e to the power of 1000 volt by T minus 1. From this e to the power of 1000 volt by T is equal to 5 plus 1, that value is equal to 6. So if you substitute this value here, you can get the 1000 divided by the 300 into 5, that value is e to the power of 1000 V by 600 is 6 into 0.01. If you see this 1000 into 0.01 value, you can write it as 10 into 6 divided by the 300. 0 get cancelled. You can see this value is cancelling in 5 times. Finally, you will get 1 by 5 milliampere. That value is 0.2 milliampere. This is error in I. Error in I can be written as 0.2 milliampere. Observe this carefully, how I calculated the error in I. So this is a 0.2 milliampere. First option is the correct option. Just go through this. First I calculate. First I have written I term, differentiated that I term. Just I have substituted the T value, that is also not required. I calculated from the given data e to the power of 1000 V by T value and substituted there. Okay. Now I will move to this other question. This is 2015 advanced question. The energy of a system as a function of time t is given as Et is equal to a square e to the power of minus alpha t, where alpha is 0.2 seconds, 0.2 per second. The measurement of A has an error of 1.25%. If the error in the measurement of time is 1.50%, the percentage error in the value of E of t at t is equal to 5 seconds is. You can see that energy, according to given question, energy E of t is equal to a square into e to the power of minus alpha t is given. Now you need to calculate the percentage error in E. For that, what I am doing is, again I am differentiating with respect to the t. Differentiate. Okay. If I differentiate this above relation, I can write it as dE is equal to a square. A square is nothing. You can see that there is an error in A also. Okay, that error in A is 1.25% is there. We can see 1.25% here. So I can write it as a square, error in this a square is 2a into dA e to the power of minus alpha t. I am using like a UV method. So I can write it as u into dv plus v into du. The differentiation process is that I am applying. So plus again I can write it as a square into minus alpha into e to the power of minus alpha into alpha t into dt. Observe this carefully. Let us consider this is the second equation, and first equation a is equal to a square e to the power of minus alpha t I am treating as a first equation. Now if I do like second equation by first equation, I will get the dE by E is equal to 2a dA e to the power of minus alpha t whole divided by the a square into e to the power of minus alpha t plus I can write a square minus alpha into e to the power of minus alpha t dt whole divided by the I can write the again a square e to the power of minus alpha t. If you see that e to the power of minus alpha t and e to the power of minus alpha t get cancelled, a one time get cancelled, e to the power of minus alpha t, e to the power of minus alpha t get cancelled, a square and a square get cancelled. If I write the percentage error in E, delta E dE by E into 100 is equal to percentage error I am writing, error in E. dE by E into 100 is equal to, I can write the value is 2 into dA divided by the A into 100 plus error. This is the error in negative value term is there. No, this term I should not take the any negative value, as it is alpha I have to write into dt into 100 you will write. Okay. Now if you see the values, alpha is equal to 0.2 is a value, dA by A into 100 value is given that 1.25 percentage. So I can write 1.25 percentage. Similarly, alpha value is given in the question, that value is 0.2 per second. Okay, 0.2 is given, and again we can see that dt by the error in the measurement of time is 1.5 percentage is given. dt by t into 100 value is equal to 1.5 percentage. If it is 1.5 percentage, I can write dt into 100 is equal to 1.5 percentage into t. They are asking at t is equal to 5 seconds. You see here what they are asking, 5 seconds. So I am writing 5 seconds. dt into 100 can be written as 1.5 into 5. I can get the 7.5 percentage. Now substitute there. dE by E into 100 is equal to 2 into dA by A is 1.25 percentage. Plus alpha value is 0.2 into dt into 100 is 7.5 percentage. If I write the all values, 2 into 1.25 is 2.50 percentage plus 7.5 into 2 is 15 percentage. 7.5 into this 1.5 percentage, sorry, 1.5 percentage. If I write the 2.5 plus 1.5 percentage value, finally I will get the 4 percentage. So my required answer is what, here 4 percentage. We can see answer is 4. Okay, observe this carefully. Next question. Using the expression 2d sin theta is equal to lambda, one calculates the value of d by measuring the corresponding angles theta in the range theta is 0 to 90 degrees. The wavelength lambda is exactly known and error in theta is constant for all values of theta as theta increases from 0 degrees. Now you can see here wavelength lambda is there, no, that is exactly known term. Okay, now I am taking the 2d sin theta is equal to lambda. If 2d sin theta is equal to lambda is there, I want like d value. D is equal to, I can write lambda by 2 into sin theta. That lambda by 2 into sin theta can be written as lambda by 2 into cosecant theta. Now I want like a differentiation of above relation. Differentiation. If I differentiate the above relation, I can get the differentiation of d value can be written as, see, for our convenient, what I am taking is, instead of taking the d value here, d value, we will take like this, capital D of D. Okay, differentiation. Okay, differentiation I am doing capital D here. Okay, D of D. Why? Because generally we will write small d, no? Yeah, small d is there, that's why capital D I am writing. If I differentiate this, I can write the lambda by 2 into cosecant theta. Differentiation is minus cosecant theta into cot theta d theta. This is my differentiation term. If you see this, if theta is increased from, if theta increases, cosecant theta, what will happen, as theta is equal to 0 degrees is there, you can write it as sine 0 is 0, cosecant 0 also 0 only. Okay, and if theta is equal to 90 degrees is there, cosecant theta value will be increases. But cot theta value, if you see now, that cot theta value at theta is equal to 0 degrees, we can write it as cos 0 is 1, sin 0 is 0, infinity is there. So infinity into 0 is infinity only. Again at final stage we can see that we will get like a other decreasing value. So finally we can say that d of d is decreases. So absolute error in D. What is D here? Absolute error in D. Absolute error in D. Absolute error in D. Error in D. Now if I want to calculate the fractional error in D. Fractional is nothing but relative error. Fractional error or relative error can be written as d of d divided by the d. This is my second equation. D of d is second equation. First equation is lambda by 2 by cosecant theta. Now if I do that, 2 divided by the 1 equation, I can get the lambda by 2 into minus cosecant theta into cot theta into d theta whole divided by the, I will get like a lambda by 2 into cosecant theta. If I see that lambda by 2 get cancelled, I no need of this minus sign. Cosecant theta and cosecant theta get cancelled. Why I don't need the cosecant theta? Reason is errors, these negative terms are not required. Okay, d of d by d can be written as, that means fractional error, we can write it as cot theta into d theta. Cot theta into d theta. Now you can see as theta increases, at 0 degrees cot theta value, we can see what will happen to cot theta. Cot theta value at 0 degrees infinity is there, at infinity its value is 0, so it is decreases. So you can see cot theta will be, fractional error is decreases. Option 4 is the correct option. Okay, you can see here at theta is equal to 0 degrees, cot theta value is equal to how much? Cot theta value is infinity, not defined. At theta is equal to 90 degrees, so cot theta value is 0. As theta increases, theta is increasing from 0 to 90, cot theta value is decreasing from the infinity to the 0. Okay, that's why we can say that the fractional error is in D is decreasing. Okay. Next question we are going to see. You can observe that next question. This question they have asked in advanced 2018 paper. This is the given data. So this is like a paragraph only. It is just explaining that how to write the fractional error or relative error. Whenever the delta y, here delta x by x is very less than 1. Delta y divided by the y very less than 1. In that case, higher power of these quantities can be neglected. Then you can write the z is equal to x by y term is there. You can see here z is equal to x by y term. This z is equal to x by y can be written as delta z is equal to z into delta x by x plus delta y by y. By using that given concept we have to do these questions. Consider the ratio r is equal to 1 minus a by 1 plus a to be determined by using the dimensionless quantity a. If the error in the measurement of a is delta a by a is very very less than 1, then what is the error in delta r? According to question, we can see that r is equal to given that 1 minus a divided by the 1 plus a. Now I am going to write the error in relative error in r. Relative error in r can be written as relative error in r can be written as delta r divided by the r is equal to, you can write it as delta of 1 minus a whole divided by the 1 minus a plus delta of 1 plus a whole divided by the 1 plus a. Okay, you can see that how to write this. They are asking only what is the error in delta r, they are not asking the relative error. Okay, so now you can see that delta r is equal to r into I am doing like LCM 1 minus a into 1 plus a term will be there LCM, then you can write it as delta delta you can write it as here what is the error in this delta into 1 minus a, you can get the delta a only. Error in a can be written as delta a only. Why? Because 1 is the number will not have anything. So finally you can see that delta a into 1 plus a plus delta a into 1 minus a. If you write the relation, r value is 1 minus a by 1 plus a is r into delta a plus a into delta a, next again plus delta a minus a into delta a whole divided by the 1 minus a into 1 plus a. If you write 1 minus a into 1 plus a, we can see 1 minus a and 1 minus a get cancelled, minus a delta a and plus a delta a get cancelled. Finally you can see that delta a plus delta a is 2 delta a by 1 plus a into 1 plus a, you can write it as 1 plus a whole square. This is the error in r. You can see the second option, B option is the correct option, 2 delta a by 1 plus a whole square. Similarly, you can see the next question. In an experiment, the initial number of radioactive nuclei is 3000. It is not the second question actually. In 2018 paper 1 they have given that passage question. First question is this, and now we are doing the second question. Okay, in the second question they have given, in experiment the initial number of radioactive nuclei is 3000. Initially any nucleus is there that is having like a 3000 nucleus are there. Okay, it is found that 1000 plus or minus 40 nuclei is decayed. So now decayed nucleus are, decayed is 1000 plus or minus 40, nothing but it is decayed. Now we are writing undecayed is how much? Undecayed, nothing but at any time t or number of nuclei present at any time t, nuclei present at any time t, at any time t, or active nucleus is n is equal to, we can write it as 3000 is initial value, 1000 is decayed. So you can write it as 2000 plus or minus 40 you can write. This 2000 is number present, this value 40 is decay, actually error in that decay. Maybe that is 1000 plus 40 or 1000 minus 40, like that. Error is dn. Now we can see that as per the question, you know that relation at any time t n value can be written as n naught into e to the power of minus lambda into t. Okay, they are asking that the error in delta L, that's all they are asking, error in delta L only they are asking. Okay, now we can write the n divided by the n naught is equal to e to the power of minus lambda into t. Now you can write the value is, just to bring the exponential term left side, we can get the logarithm ln n by n naught is equal to minus lambda into t. Now you can write the value as lambda into t is equal to ln n naught divided by the n. again lambda is equal to, you can write it as 1 by t times the ln n naught divided by the n. This is my lambda value, but I want like error in lambda, that I am doing like a differentiation on this. If I differentiate the above relation, why I am differentiating, again I am telling whatever error is there comparatively 3000 and 10,000 1040 error is small only, and that too they have given x is very very less than 1, that we have to apply. You can see here log of 1 plus x is equal to, you can treat it as x they have given. Okay, now you can see d lambda is equal to 1 by t is constant, differentiation of x log x is equal to 1 by x, so you can write 1 by n naught divided by the n, you can get. Similarly it is like a so you can write it as n naught by n is there, that's why you write minus 1 by n square into dn you write. Okay, now if you write delta d lambda value is equal to 1 by t into n divided by the n naught minus 1 by n square, that minus is actually you will not consider while doing the problem. n and n get cancelled. Now finally you can write it as d lambda value is 1 into dn divided by the n naught into n is there. n naught into n is there. You just observe this. According to the question, you can write it as n value I have written and dn value is given. How much value of dn is there here? dn is 40 is there. Okay, if it is 40, according to question what they are asking, what is the delta lambda value, delta lambda or d lambda value, just you can do the calculation and get the answer for that. Okay, actually first I have done for this n naught, no I forgot to write n naught here, n naught also write. Why? Because differentiation, this is log differentiation, this term is what here, n naught by n, n differentiation is 1 by minus 1 by n square. Okay, we can see n naught and n naught also get cancelled. Here I should not write the n naught value. Now you can see that relation of this value is t is 1 I have written already, dn is 40, n value present is 2000 is there, 40 get cancelled, this we can write it as 50 times, and dn value already written, so finally you will get the 0.02. This is my d lambda value. Calculation part we can do, this is the only process, we can observe this carefully how I have done the process. Okay, C option is the correct option. Next question, this is the JEE Mains 2021 question. If the length of the pendulum in pendulum clock increases by 0.1%, the error in the time per day is what? Now you can see the time period of simple pendulum, you can write it as simple pendulum. You know the formula is t is equal to 2 pi root over L divided by the G. Regularly you will get t is equal to 2 pi root over L by G. According to question, the length of the pendulum in pendulum clock increases by 0.1%. The error in time per day is what? Okay, you can see here percentage error in time period. Delta t divided by the t is equal to 2 pi is constant. G also there is no error in this, so you can write it as 1 by 2 times the delta L by L. Sorry, they are asking percentage error, no, delta t by t into 100 is equal to 1 by 2 into delta L by L into 100. So I have written that. Now you can write it as 1 by 2 into delta L by L into 100 value, they have given 0.1%. If I write this 0.1%, I can get the value is length of the pendulum clock increases by 0.1%. Length is increases by 0.1%. They have given. You need to calculate the time per day is how much. You can see that time time period t is equal to t divided by the n. Delta t by t into 100 is equal to, you can write it as delta t by t into 100 we can write. Okay, or if I write the delta t divided by the t is equal to how much, delta t by t also you can write. If I write the delta t value, delta t divided by the t into capital T also you can write, or you can write the delta t is equal to delta t by t into small t also you can write. You just observe that what they have given here, 1 by 2 into percentage value they have given, I think change value only they have given, length only changed by 0.1 percentage. If you take this is a 0.1 percentage into time taken t is per day, one day is having 86,400 seconds. You substitute there 86,400 seconds. If you write the values 1 by 2, 0.1 percentage means 1 by 1000 into 864 into 00. You can see two zeros get cancelled. Here we can get the 4 times, 3 times, 2 times by 10 is there. We can get the 43.2. Delta t value is this much. Okay, earlier instead of taking the delta t by t into 1000, just you take delta l by l only. Okay, only they have given delta l by l value only, they have given 0.1 percentage. Okay, just you do this percentages also, here also you remove that percentages. Okay, just here only one thing is sufficient, delta t by t is equal to this. 43.2 percentage is the answer. Go through this question. Next one, you can see next question as, in a simple pendulum experiment for determination of acceleration due to gravity g, time taken for 20 oscillations is measured by using watch 1 second. You see here, according to question, 1 second is the least count in time. We can write delta t is equal to 1 second. The mean value of time taken comes out to be 30 seconds. Nothing but time t is given that 30 seconds. I have taken 30 seconds. The length of the pendulum is measured by using meter scale. Least count of length is given that 1 millimeter. I can write it as delta L is equal to 1 millimeter, that is equal to 0.1 centimeters. Next, the length is given, measured value is 55.0 centimeters. I am writing L is equal to 55 centimeters, 0 centimeters. Now you need to calculate what is the percentage error in G. Delta G by G into 100 is question mark. Now we have the time period formula, T is equal to pi root over L by G. You can write it as you want G. First you make the G expression towards the left side. T square is equal to 4 pi square L divided by the G. Now you can write the G is equal to 4 pi square L divided by the T square. If I write the percentage error in G, delta G by G into 100 is equal to 4 pi square is a constant term, no need to write the any error in that. Delta L divided by the L into 100 plus 2 into delta T divided by the T into 100. Substitute the all the values, whatever values are given. Delta L by I have written delta L value, delta T and T. So finally you will get the relation as 0.1 divided by the 55.0 into 100 plus 2 into delta T. I am writing T is equal to, earlier also I have written T divided by the N. So we can write it as delta T by T into 100 is equal to delta small t divided by the T into 100. You can write it as the value is 1 divided by the 30 into 100. You can say delta T is 1 second into 100. I can write the 1 divided by the 30 into 100. You do the calculation, you will get the value is 6.8 percentage. This value is 6.8 percentage. GA how to bring left side and do the calculation. See next question. The period of oscillation of simple pendulum is given T is equal to pi root over L by G. Measured value of L is 1.0 meter from the meter scale, having minimum division of 1 millimeter. Again I am writing like L is equal to given that 1.0 meters and delta L value is given 1 millimeter, that is 1 into 10 to the power of minus 3 meter, and it is given that one complete oscillation it takes the 1.95 seconds. Measured stopwatch is 0.01 second. Resolution delta T is 0.01 seconds and T is given that 1.95 seconds. Okay, now you can use the same thing. G is equal to 4 pi square L divided by the T square term is there now. By using that, delta G by G into 100 is equal to delta L by L into 100 plus 2 into delta T divided by the T into 100. You substitute the all the values, whatever values are given, you can get the value is 1.13 percentage. Substitute there, you will get the 1.13 percentage. Okay. Next one, this is a JEE Advanced 2018 paper 1. Student 1, 2, 3 performing experiment for measuring acceleration due to gravity using simple pendulum. So data is given, you can see that delta L term is given, delta L is equal to this, and delta T is given that 0.1. This is my T terms, you can see here, this is total time is given, that is T. You want T, delta L and L, you can see these terms are L terms. Okay, now I am writing G is equal to, you can write it as delta G by G as per the question. Delta G divided by the G into 100 is equal to, you can write it as delta L divided by the L into 100 plus 2 into delta T divided by the T into 100. Now observe this first case. Student 1 is writing that delta G by G value is how much? Delta L value is 0.1 centimeter divided by the 64 into 100 plus 2 into delta T by T value is, we can write it as 0.1 divided by the 128 into 100. This is the person 1. Now if you see the student 2, you can write the again same thing, 0.1 divided by the 64 into 100 plus 2 into 0.1 divided by the 64 into 100. And student 3, whatever he measured is 0.1 divided by the 20 into 100 plus 2 into 0.1 divided by the 36 into 100. So I am taking here delta T by T into 100 is equal to delta T by T into 100 value I am taking. Okay, I am not calculating any time period relations here. Just observe the relations. As 1 by 64 into 0.1 by 64 is there. In the next case also 0.1 divided by 64 is there. In right side equation 0.1 by 128 is there. Here 2 into 0.1 into 24, 1 by 64 is there. Nothing but E2 is greater than E1. It is clear that E2 is greater than E1. Reason is 64, denominator is reduced, so E2 value will increase. Next case, if we see that in student 3, he is measuring like a first term is 0.1 by 20 is there. Nothing but denominator is reduced here comparatively above case. Okay. Similarly, comparatively above case 1 by 64 is there. Here 1 by 36 is there. So nothing but E3 is greater than E2. Finally, we can say that the student measured delta G by G into 100 is greater than the second student, that is greater than the first student. So it is clear that E1 reading is a minimum reading. This reading is minimum reading. So option B is the correct option. Observe this. Next one, in 2017 paper 2, they have given that a person measured the depth of well by measuring the time interval between the dropping a stone and receiving the sound of impact with the bottom of the well. The error in measurement of the time is delta T is 0.01 seconds and he measured the depth of the well to be L is equal to 20 meters. Take the acceleration due to gravity G is equal to 10 meter per second square and the velocity of sound is 300 meter per second. Then fractional error in measurement of delta L by L is closest to what? You observe the question properly. A person is dropping. Dropping is nothing but is initial velocity of stone is 0. Let us consider bottom there is a water is there. Now this stone is hitting this. Actually it is hitting this. It is traveling a distance L. Now after reaching this sound is produced. So sound wave is traveling from the bottom point to the again the person who is standing here. Person is there, no, he is hearing the sound. Now whatever time traveled by the whatever sound wave is there, no, that sound wave I am taking as t2, that is equal to distance traveled by the sound wave L divided by the speed of sound v. Okay, in first case what is the time taken? As it is fallen, freely falling body, you can write the time taken is root over 2h by g, here h is L, so you can write it as this t1 I am taking. So time to reach the sound is total time taken. T can be written as I can write the t1 plus t2. Okay, that actually they have given the capital T is given. We can take that. T1 value is root over 2L by G plus L divided by the V. That is the relation. Now differentiate above relation. Differentiate the above relation. If you differentiate the above relation, we can write that dt is equal to root over 2 by g is taken outside, it is a constant. Root L differentiation 1 by 2 into L to the power of 1 by 2 minus 1, so we can get 1 by root L you will get into dl plus dl divided by the v. This is my dt value. Okay, now I want like dt value is they have given 0.01, dl by delta L divided by the L we want. Okay, delta L by L value how do you get? You can see here L is given that 20 meters. Now you can calculate the 0.01 is the dt value, and root over 2 divided by the g is given that 10. We can take the 10 into 1 by 2 into dl is as it is, you will write root L value is root 20 plus dl divided by the v value is 300 is given. Now we don't want dl value, you want dl by L, so just divide both the sides with L, both sides with L. Calculation we can do any manner. 0.01 divided by the L is equal to, I can write the root over 2 divided by the root 10 into 1 by 2 into dl divided by the, we can write it as 2 root 5 we can write, no, that we can write 2 root 5. Then you can write the int L plus dl by L and 300 also there. You just observe that. Now you can write the root 2 by root 10 is you can write it as root 5. So you can write it as 0.01 divided by the, as L value is given 20, you can write it as 20 is equal to 1 by 2 into 2 is 4, root 5 into root 5 is 5, dl divided by the L plus dl by L into 1 by 300 term is there, 1 by 300. Now we only term is unknown term is what here required term is dl by L only in both the sides. Left right side is the dl by L. Now I am taking this is this 20 and 20 get cancelled. If it is cancelled like a 20 times, we can get the 15. Okay, I can write the 0.01 is equal to dl by L is taken common, 1 plus 1 by 15 is there. I can write the 0.01 is equal to 16 divided by the 15 dl by L. Now I can write the dl divided by the L is equal to 15 into 0.01 divided by the 16. Now you just observe that what they are asking actually, the fractional error in measurement of this means actually here they are asking fractional error, but finally they have given percentage value also. We can see what is a percentage value. 15 by 16 approximately you can get the 1%. Okay, the first option approximately 1%, closest value only we can see that how much percentage is there. Next one, in JEE 2010, they have asked one question. A student uses simple pendulum exactly 1 meter length. See here, 1 meter length is 1 meter only. There is no error in L. Okay. Next, determining the G acceleration due to gravity, he uses the stopwatch with the least count 1 second. Nothing but delta t value is given 1 second, and given that 40 seconds for 20 oscillations. 40 seconds. So t is equal to 40 seconds is given. For this observation, what are the percentage error in G they are asking. What is percentage error in G? Delta G divided by the G into 100 is equal to, we can write it as delta L by L is not there. So 2 into delta T divided by the T into 100 you can write. I am taking delta T by T into 100 is equal to small delta T by T into 100 I am writing. So that's why you can see here. So I can get the 2 into delta T value is how much? 1 divided by the 40 into 100 you can write. So finally you can get the 0 0 get cancelled. It is 2 times. So we can get the 5%. Option C is correct. Now error in delta T in measuring the T in the time period of 0.05 seconds. We can see delta T by T is equal to delta T divided by the T. That value is 1 by 40. Again, delta T is equal to 1 by 40 into T. So we can see what is the time period. Time period can be written as capital T is equal to time per number of oscillations. Time is given that 40 seconds and 20 oscillations are there. 40 divided by the 20, you will get the 2 seconds is the time period. You substitute there 1 by 40 into 2 seconds. If you substitute there, you will get the 1 divided by the 20. The value is 0.05 seconds. This is my delta T. Error in time period is there, delta T. Okay. So first option is the correct option. Check this. Next question, if you see that the following observations were taken for the determining surface tension D of water by capillary method. D is given, H is given, G is given, and all values are given. We have to calculate the relation. If you calculate the error in T, T can be written as RHG divided by the 2 into 10 power 3. Error in T can be written as delta T by T into 100 is equal to delta R divided by the R into 100 plus delta H divided by the H into 100 plus delta G by G into 100. Wherever error is there, you can take the error values. So delta R by R value, if you write that R is not there, you can take that delta R is equal to, actually you can write it as D by 2. So you can write the delta R by R into 100 value can be written as delta D by D into 100. Just substitute the delta D by D into 100 values only there. If I take the delta D by D into 100 value, you observe carefully here. Delta D, if you see that the error in this one is 2 decimal places are there. So error is nothing but we can see that 0.01 into 10 power minus 2 divided by the 1.25 into 10 to the power of minus 2. Error is nothing but here how many decimal places are there? No, number of decimal places gives error or uncertainty in the measurement. Later we can say precision value also. This is only precision also. Okay. Now you can see into 100 plus delta H divided by the H. What is the H value? Again you can see here 1.45 is there. We can write it as 0.01 into 10 power minus 2 divided by the 1.45 into 10 to the power of minus 2 into 100. Okay. So anyway, G term is that is very small value only. No need to consider that. 10 power minus 2, 10 power minus 2 get cancelled. 1 divided by the 1.25 is 5 by 4. Plus you can write it as 10 power minus 2 and 10 power minus 2 get cancelled. 0.01 100 also get cancelled. 1.45 value is there. That 1 by 1.45 value is there. We can write it as 4 by 5 value is 0.8 plus Again you can see this value is approximately you can get the 0.71 by 1.4, approximately you can get the 1.5 percentage. Here delta G by G, there is no error in this, so you can write the second option. Okay, using G is equal 9.8 meter per second square, simplified relation is given. Okay, next one. In the density of measurement of the cube, the mass and edge of the cube is measured as mass is given and length is given. So you can write the volume is equal to L cube, you can write. So density, if you write that mass divided by the volume, so you can write m divided by the L cube is the values. If you see mass is 10 and delta m is given, so you can see m is equal to 10.00, delta m value is given 0.10. Next one, L value is given that 0.10, delta L value is given 0.01. You can write delta rho divided by the rho is equal to the error in measurement of density, that they are asking only error. Okay, delta rho they are asking. We can write delta m divided by the m plus 3 into delta L by L. Again you can write delta rho is equal to rho into delta m divided by the m plus 3 into delta L divided by the L. I can calculate the what is the rho value. M is nothing but 10 divided by the L cube value is 0.1 whole cube. So if you substitute the values, you can get the value as 10 divided by the 10 to the power of minus 3, that value is 10,000, means 10 to the power of 4 is there. You substitute the all values here, you can get the 3100 kg per meter cube. Okay, next one. JEE Mains 2021, they have given in order to determine the Young's modulus of wire radius 0.2 centimeters. So you can see radius of the wire is Young's modulus. I hope everyone knows that. If you take the any wire, okay, this is a wire having length L, radius of the wire is R. Whenever any load is attached to this, we can see length of the wire will be increases to the certain value. At the same time, radius will be reduces. Okay, now you can see whatever the extension is there, that I am taking x. Okay, x is the extension in the wire. I am taking x is the extension in the wire. X is extension in the wire. Now what was the given use? We can see here. Radius r is given 0.2 centimeters. Delta r is given 0.001 centimeters. Length is given that L is equal to 1 meter. Next, delta L is given that 1 millimeters. 1 millimeter is 1 into 10 to the power of minus 3 meters. Weight of the body is given, mass is given 1 kg. Next, delta M is given that 1 gram. 1 gram is 10 to the power of minus 3 kg. I have written delta M value. Next, elongation X is given that 0.5 centimeters. And delta X value, error in delta X they have given 0.001 centimeters. Next, you need to calculate what is the Young's modulus error, percentage error they are asking. Percentage error is question mark. Okay, what will percentage they are asking? Just you can calculate the percentage error in this. According to question, you can write the first what is the Young's modulus. Young's modulus y can be written as F by area, means longitudinal stress divided by the longitudinal strain, delta L divided by the L. That strain I am taking this as extension is there, no, that X divided by the L I am taking. Okay, F is nothing but mg, A is nothing but pi r square whole divided by the X divided by the L. Now you can write y is equal to mgl divided by the x into pi r square. If I write the error in y, percentage error in y, delta y by y into 100 is equal to delta m divided by the m into 100 plus they have not given that error in G, so we can eliminate the G. Next, delta L by L into 100 plus delta X divided by the X into 100 plus 2 into delta R divided by the R into 100. I have given the all values. You can see delta R and R, delta L and L, delta M and M, delta X and X I have given. You just substitute the all values, we will get the required answer. 1.4 percentage you will get. Okay, so answer for this one is 1.4 percentage. Use this properly Young's modulus. By using Searle's method, you can calculate the extension in the wire. Actually here stress strain graph also you will draw there. Now next question based on the same Young's modulus. A student is determining the Young's modulus of the elasticity using the formula y is equal to mg by L cube 4b d cube delta. Delta is here elongation. The value of G is taken to be 9.8 meter per second square without any significant error. Nothing but no error in G. No error in G. Each observation can be observed. So all values are given. M is given, delta M, both are values are given. This is M. Delta M value is 10 to the power of minus 3 kg is delta M. Next, this is length L and here 10 to the power of minus 3 meter is delta L. Next, you can see B is given. You can see here 10 to the power of minus 2 centimeter is delta B, that is delta B. Next, you can see D is given, so you can write delta D value is 10 to the power of minus 3 centimeter is delta D. Next, depression is given delta, and here also they have given D delta value, sorry, delta. Okay, delta value is same 0.01 millimeters only. All values I have written. You can use the relation y is equal to mg L cube divided by the 4b d cube delta. If you write the delta y divided by the y is equal to the fractional error only they are asking, delta m divided by the m plus g is not having any error, 3 into delta L divided by the L plus delta B divided by the B plus 3 into delta D divided by the D plus delta by delta. Okay, you substitute all values whatever they have given, you will get the answer is 0.0155. You can try this. How to calculate you see it, but you try it, don't leave that, you can try that. Okay, next question. A student, this is the IIT JEE 2007 paper 2. A student is performs an experiment to determine Young's modulus of wire exactly 2 meter long. You can see no error in L. No error in L. Okay. Next, by Searle's method. Searle's method means Searle's method will be used to measure the Young's modulus of wire only. Okay. By Searle's method, in a particular reading, the student measures the extension in the length of the wire is they have given x is equal to 0.8 millimeter. With uncertainty, delta x is given 0.05 millimeters. Next, load exactly is given, mass value exactly they have given, mass value is equal to 1.0 kg, no error in M. No error in M. And one more thing they have given, L. L is equal to 2 meter long, no error in L. Okay, next, the student also measures the diameter to be 0.4 millimeter. So they have given diameter, I am taking this as a capital D, is equal to 0.4 millimeter. So I can write the radius is 0.2 millimeters. That is radius is R. Okay. Next one, error in diameter. Similarly, error in radius both will be same. We can write it as delta R value is equal to 0.01 millimeter. Now you need to calculate the there is no error in G. Actually, G is exact. G is exact. That value is 9.8 meter per second square. You can see Young's modulus obtained in the reading is equal to how much? I am taking y is equal to earlier I have written mg divided by the area pi r square into x divided by the L. That is a strain. Strain is x by L. So delta y divided by the y is equal to, we can write it as delta m is not there, g is not there, delta L also not there. So this first three terms are there now, mgl are no error. No error in upper part. So bottom part only there. 2 into delta r divided by the r plus delta x divided by the x. You can see here x delta x. Next we can see that r delta r. Now according to question, if we substitute all the values of this, we can see everywhere 2, 2, 2, 2 is there. We can write the 2 into 10 to the power of 11 Newton per meter square is the y value. No need to calculate that. Okay. Now you can calculate the values of this. Delta y is equal to y into 2 into delta r by r plus delta x divided by the x. Y value is 2 into 10 to the power of 11. 2 into delta r value is, we can see that 0.01 divided by the r value is equal to 0.2 plus delta x value is 0.05 divided by the 0.8. You calculate this, approximately you will get the value is 0.2 into 10 to the power of 11 Newton per meter square. This is a delta y value. So they are asking y plus delta, y plus or minus delta y value is this second option. Okay, they are asking delta y value. Observe this carefully. Next question. In 2021, they have asked in JEE mains. In the experiment Ohm's law, potential difference 5 volt is applied across the end of the conductor of length 10 centimeter and diameter of 5 millimeter. The measured current in the conductor is 2 ampere. The maximum permissible percentage error in resistivity of a material is what? So you know that R is equal to resistance, R is equal to, we can write it as rho L divided by the area. Rho L divided by the area. You see in the question, diameter of the wire is given 5.00 millimeter is given. You can write the value is rho L divided by the pi into r square also. R is equal to d by 2. You can write it as rho L divided by the pi into d square divided by the 4. Again, resistance R can be written as voltage by current. That value is 4 into rho L by pi d square. Now we want rho value. So rho is equal to, you can write it as V into pi d square divided by the 4 into L into I. Okay. Now you need to calculate maximum permissible percentage error in resistivity. That delta rho by rho into 100 is equal to, you can write it as delta V by V into 100 plus 2 into delta D by D into 100 plus, if it is possible, delta L by L into 100 plus, if it is possible, delta I by I into 100. Wherever error is there, you can check here. Okay. If you see the question, potential difference is 5 volt is applied across the ends of the conductor and length is given 10.0 centimeter, diameter is 5.00 millimeter, the measured current is 2.00 ampere. The maximum permissible error means we can calculate all the values. You substitute that delta V value is 0.1 divided by the 5 into 100 plus 2 into delta D value is 0.01 divided by the 5.5 into 100 plus delta L by L. Delta L by L value you can see 10.0 centimeter. So you can write it 0.1 divided by the 10 into 100 plus delta I by I value 2.00 is there. 0.01 divided by the 2 into 100. You do the calculation, you will get the answer is 3.9 centimeters. 3.9 you will get. Percentage error in resistivity is 3.9. Okay, 3.9 percentage. Go through this. Next, an aluminum wire is stretched to make its length 0.4 percentage larger. The percentage change in resistance is equal to how much? Here also you can see whenever a wire is taken, Let us consider resistance is R, resistivity is rho, length is L, and area is A. If it is stretched, same wire, it is stretched. Same wire, whenever it is stretched, we can see L dash becomes something like a new length is I am taking like a L dash. New radius is R dash, rho is same only, A dash is this. Now L dash is increased. Volume remains constant. Volume remains constant. If volume is remains constant, we can write it as A dash L dash is equal to A into L only. A dash is equal to AL divided by the, we can write it as L dash. Okay. Now if I write the new resistance R is equal to, R dash is equal to rho into L dash by A dash. Rho into L dash only, A dash value is AL divided by the L dash. So finally rho L dash square, you can write it as rho into A dash value is AL divided by the L dash is there. Okay. So if I write the L dash value, what value you can get here? Rho L is volume only, constant. Rho is constant. We can see R A dash is proportional to L dash square, or you can write R is proportional to L square. Whenever it is stretched, we can see that R is directly proportional to square of the length. By using this, we can see that only length is given now. I can write it as delta R divided by the R into 100 is equal to, it is proportional to L square. So we can write 2 into delta L divided by the L into 100. 2 into delta L by L value is how much? 0.4 is given. We can write 0.4 percentage. If you write 0.4 percentage, finally you will get 0.8 percentage. You can see 0.8 is the correct answer. We can tick that. Next, two resistors R1 is 4 plus or minus 0.8 ohm, R2 is 4 plus or minus 0.4 ohm are connected in parallel. The equivalent resistance of their parallel combination will be. Now you can see in parallel connection 1 by R is equal to 1 by R1 plus 1 by R2 is there. If you calculate 1 by R is equal to R value, this is R1, this is delta R1, and 4 is R2 value, and delta R2 is 0.4 is there. 1 by 4 plus 1 by 4 you will get 2 by 4, finally you will get 1 by 2. Now R value is equal to 2 ohm. So you can see there are two options are there, second option and third option. Now you need to calculate error in this. So for this, differentiate. As errors are small, you can differentiate. Now according to differentiation, minus dr by r square is equal to minus dr1 by r1 square plus minus dr2 divided by the r2 square. Now we can get the dr divided by the r square is equal to dr1 by r1 square plus dr2 divided by the r2 square. Again I am doing, why I am differentiating is these errors are small. Errors are small. Errors are small. We can differentiate. We can differentiate to find error, to find relative error or errors. Errors. Okay. Now you can see that dr by r only we want. Dr by r is r into dr1 divided by the r1 square plus dr2 divided by the r2 square. You substitute the value of r is 2. dr1 value you can see 0.8. 0.8 divided by the 4 square. 0.4 divided by the next one also 4 square. If you calculate, you will get the answer is 0.3 only. We can write the value is 0.3. What they are asking actually, delta r plus r, now you write this is dr value. Dr value is r square. You can write the dr value is r square. R square is 2 square. Okay. Dr value is equal to 0.3 ohm. Just substitute there, R value is there, 0.3 is there. You can get the answer for this. Okay. Next, same question now, if they ask like percentage error. Percentage error means dr by r into 100 you have to write. Okay, you bring r value down only in that case. Okay, next question. A wire is 1 ohm as the length 1 meter is stretched to its length is increases by 25 percentage. The percentage change in the resistance of the resistance to the nearest value is equal to how much? Again I am telling, I am taking this as resistance R is equal to 1 ohm, length is equal to 1 meter is there. It is stretched by 25 percentage, nothing but you can say that 1 plus L dash is equal to 1 plus 25 percentage is nothing but 1 by 4, that is equal to 5 by 4 meters is the new length. If it is 5 by 4 is a new length is there, you can calculate the new length, you can get the value is how R value is proportional to this. R is proportional to L square. You can write it as delta R divided by the R into 100 is equal to 2 into delta R delta L divided by the L into 100. If you do this, 2 into delta L by L value is how much here? Delta L value, you can see that what is the delta L value. If you write the delta L value, you are getting like a 1 by 4 divided by the, I will tell what is exactly process. Okay, first you apply this method, I will tell. Okay, 2 into 1 by 4 into delta L. What is the L value? L is equal to 1, so you can write it as into 100. You can see 2 times get cancelled, you will get the 50 percentage. You will get the 50 percentage, but it is not the correct relation. We can see initial R value is 1 ohm. What is finally how much value is there? We can see here. As R is proportional to L square, R final, this R1 you write, R2 is equal to, you can write it as L square terms, you know, that we can write it as rho L by A term. If you write that 5 by 4 whole square into 1 you will get, that is 25 by 16 ohm, that is a R2. But you have to write like a percentage change in R. Change in R, we can write it as delta R divided by the R1 into 100. Delta R value is, we can write R2 minus R1 by R1 into 100. You substitute there, delta R2 divided by the R2 minus R1, 25 divided by the 16 minus 1 divided by the 1 into 100. You can get the 25 minus 16 is 9. 9 divided by the 16 into 100 you can get. So 9 by 16 into 100 value, if you write the value, approximately you can get 900 divided by the 16 term, you will get approximately 56 percentage. This is actually process, this actual process. This is whatever term I have taken, this is wrong process. Why I have taken the question now? Reason is this only. Reason is, you can see whatever length increase it is there, no, that is not small. Okay, if you want to write here, note here the error in length is not small. It is not less than 10 percentage. It is more value. It is more value. Like 25 percentage is there. We cannot apply errors like delta R divided by the R into 100 is equal to N into delta L by L into 100. We cannot apply this. We cannot apply. We can't apply this. We have to apply this change, percentage change is there, no, that we have to apply. This is the actual process. Okay, so now correct option and correct process is this process is the correct process. Observe this carefully. This is the correct process. Correct answer is this. This is a wrong process. Don't apply that. Okay, 56% is the correct option. Again I am telling, these errors I have written delta A is very less than 1. delta B is very very less than B, then only you can apply the relative error delta A by A plus delta B by B is equal to B is equal to delta Z by Z. I wrote no earlier that. Okay. You can see next one, the maximum error in the measurement of resistance, current and time for which the current flows in a material electrical circuit is 1%, 2%, 3% respectively. The maximum percentage error in the detection of the dissipated heat will be how much? You know that heat energy H is equal to I square R into T. You can write the they are asking percentage error only. Delta H by H into 100 can be written as 2 into delta I by I into 100 plus delta R by R into 100 plus delta T by T into 100. The all values are given, you can get the answer like delta I by I value is how much is given 2 into, first case they have given resistance is 1%, sorry, resistance is 1% is given, 2 into some value plus resistance is 1% plus next one current, second one is current 2%, current is 2% plus time is 3%. If you write this 4 plus 3 plus 1, 8% you will get, fourth option. Okay. Next question, JEE Advanced 2020. You can see two capacitors of the capacitance values are C1, C2 values are given, voltage is given. The percentage error in calculation of energy stored in this combination will be how much? Here capacitors are series. In series connection, you can write the value is 1 by C is equal to 1 by C1 plus 1 by C2. You just calculate what is the C1 value and C2 values. 2000 plus 1 by 3000 is there. You can get the 5000 divided by the 2 into 3 10 to the power of 6 is there. Finally you will get the 5 divided by the 6000 you will get. So 1 divided by the 5 1200. So C value is 1200 picofarad. Again, to calculate the error in this, okay, to calculate error in this, we can write it as dC by C square, differentiate, you will get the error in C. Delta C by C square is equal to delta C by C1 square plus delta C by delta C1 delta C2 by C2 square. Then you can write the delta C by C is equal to C into delta C1 by C1 square plus delta C2 by C2 square. This is a regular process. You can see this is a C1 value and 10 picofarad is a DC1. Okay. Similarly, 3000 is C2, 15 picofarad is you can see that this value is DC2 value is that. Okay. Now if we substitute these values, some value will get. Okay, I am not doing now. Voltage also they have given. This is the V and change in voltage or error in voltage is given that dV value is 0.02. If we see the percentage error in calculation of energy stored in combination of capacitors, you have like U is equal to half into C into V square. Now you can write du by U into 100. They are asking percentage error only. Du by du into 100 is equal to dC by C into 100 plus 2 into dV by V into 100. V value is given, dC by C is already we will calculate from here. dC by C into 100 value is equal to C into dC1 by C1 square plus dC2 divided by the C2 square, whole thing into 100 you will write. Okay. If we substitute the value here, this value delta C by dC by C into 100 value, you can see this value and the voltage value they have given. If we substitute there, you will get the answer. And already I have calculated this. I will show this. See, I have calculated. I got the value is 1.30. Okay, dC by C is 5 into 10 power minus 3 is there. You can write 1.30 is the answer. The answer is 1.30. Okay, observe this. Next question. In 2024, this year only, in paper 2 they have asked that the dimension of a cone are measured using a scale with least count of 2 millimeter. The diameter of the base and highest height are both measured to be 20.0 centimeter. The maximum percentage error in determination of the volume is how much? We can see cone volume. Volume of cone is volume of cone, we can write V is equal to 1/3 pi r square into L. The maximum percentage in volume delta V by V into 100 is equal to, we can write it as 2 into delta R by R into 100 plus delta L by L into 100. All values are given. You can see this is least count is delta scale 2 millimeter, diameter and base height are they have given both are to be 20 centimeters. So you can see that both are given 2 millimeters only. Delta R, delta L, both are given 2 millimeters. That is 2 into 10 power minus 1 centimeters. And R is equal to L is equal to, they have given 20.0 centimeters. You substitute there, you will get the answer. And already I have calculated here, you can see here. So pi r square by 2, pi d square by 2 by h into that, what is given? Height or diameter is given. So diameter means what you like? This is delta d is given, this is also d is given. So you can write it as delta d by d into 100 is equal to delta r divided by the r into 100. That also you can write. Okay. So if you calculate this, you will get the answer is 3. You can write the answer is how much? 3%. 2024 question, this one. You can check how simple questions they are asking in JEE Advanced also, you will see. Okay. Next one. In an experiment for determining the focal length of a thin convex lens, the distance of the object from the lens is 10. Object position is given, u is equal to 10 plus or minus 0.1 centimeter. V is given that image of real image is 20 plus or minus 0.2 centimeters. Percentage error in focal length. Actually 1 by f is equal to 1 by v minus 1 by u. We can write 1 by f is equal to 1 by v is 20 minus 1 by u value is minus 10. You substitute there 1 by 20 plus 1 by 10. You can get the value is 3 divided by the 20. So f is equal to 20 by 3 centimeters. This value is f value I calculated. Again we get like a 1 by f is equal to 1 by v minus 1 by u is there. No, you differentiate this. Differentiate. Why I am differentiating? 0.1 is there. No, that 0.1 and 0.2, they are 10% error only there. 0.1 by 10 into 100 if you write, 10% is only there. So now you can apply this differentiation, like small errors are there, that you can write. Minus df by f square is equal to, you can write it as minus dv by v square minus du divided by the u square. As a whole, you can write the df by f into 100 is equal to f into dv by v square into 100 plus du by u square into 100. All values are given. You can substitute there. F value also I calculated. You can substitute there. dv is given, v values are given. You can get the final answer. I have already done in 2023 paper 1. So finally, you are getting the value is answer is equal to how much? 1. We can check the calculation. 1 you will get. So I am rating this is 1%. This is the answer. I hope you enjoyed this. And next lecture I will give the what is accuracy, what is the precision, and significant figures, then other rounding of conditions, other questions are there related to that. Standard deviation, what is a mean deviation and standard deviation, that difference